Welcome to the first of 3 workshops offered by the Danish Reproducibility Network in the spring of 2025. Today we have 3 speakers, and we are very happy we have speakers from across Denmark, from Aarhus University, from the University of Southern Denmark, and also from Rigshospitalet here in Copenhagen. We start with Dr. Cyril Pernet, who works at the Neurobiology Research Unit at Rigshospitalet and is spearheading the Open Neural Patents project, making it possible to share and promote molecular neuroimaging across labs, a core part of open, reproducible research. So welcome, Dr. Cyril Pernet.
Yeah. So let me, so the title is supposed to be my journey into data sharing. So my journey as in my first time I do data sharing and then exemplify as I go along different stuff maybe that I learned. So my first time I wanted to do data sharing actually is not me who started it, it's my first PhD student, Chris. And what we were doing is that we were creating protocols to analyze analysis pathways dedicated to clinical, so applying functional imaging to the clinic for brain tumor patients, which means we needed to validate and do all sorts of brain imaging stuff. So cool brain imaging pictures, because why not? And then, you know, we start to do this, and then it's like, hey, maybe we can share the data. Do that. You know, it was even not something that I was thinking about at the time. And then, so we worked on that. And so we have a paper in 2013. Yes, we could already share data at that time, which was just healthy control people as a test-retest, since you want to develop a protocol, first you want to do to test it as it works. And then the paper described the data, and you know, as much as you can do in a data paper. I mean, it's also part of a large series on functional MRI. So when you go on the GigaScience website, you can check for fMRI, and then there's plenty of papers that comes up. So it's nice because it's a little bit more findable. And then you can still access the data. So I actually checked this morning, you know, just to be sure. And that's basically what it looks like. So you have a paper, the paper has a link, it takes you to their database, and then it looks like this, so you can still access. Now, of course, it looks a bit shit. Because I mean, yeah, sure, click on it, and then figure out what it is. Because so of course access is great, so I'm happy you can still access, but of course you can't really search. You need to really download to figure out what's inside every archive that's in there. So you kind of guess that maybe, you know, when you read the paper, it tells you have n subjects, it's about n tarballs. So you're like, probably that's what it is, but yeah, this is difficult. So what's good, at least, is that within all the tarballs, the data are all open data format, which means we're still interoperable. Everybody can read it. But there's no formal description, no consistent naming. Well, at least it was consistent to us at the time. There's no real metadata to document what it is, which means reusage is, well, maybe possible, but difficult. But then came something called BIDS, which is the brain imaging data structure. In this paper, you can see first author is still Chris. At the time, 2016, he has moved to Stanford. And what BIDS does is that it solves interoperability. It's basically, the best way to describe it is to go on the website, tells you what it is. So in neuroimaging, we have plenty types of data, and there was no consensus on how to do it. So first of all, it's a grassroots, so it's like researchers who come together and decide together on what the format should look like and what the naming should look like. It's not somebody who says, hey, do this. Let's work together and decide together, you know, reaching a consensus on how we should name things and organize things and document all the metadata. And so BIDS really solve that issue for people who do brain imaging. This is just a quick timeline of, so we started in 2016, and then 20 of other stuff along the way, because we started mostly for MRI, and then we do EEG, MEG, all sorts of brain imaging stuff. So from this, what did I learn? First is would be, don't be scared about sharing stuff in general, because it's a great way to expand your network, collaborate on new projects, meet plenty of new people, which is also part of the fun of doing science, right? And so to me, it's like, yeah, okay, you know, and nobody's gonna say, oh, but what you share doesn't work. They just email you and you work together and solve the problem. So that's what we do in science, right? I would say nothing is perfect. Build is great, but it's not perfect. But documentation is key. So even if we look at the old archive from Giga Science website, if I had a little bit more of a README and a little bit of explanation in there, it would already make things way easier to use. So metadata documentation is really essential in whatever we want to share. And from BIDS, what we learn also is human and machine readability. It's nice that you have like stuff that machines can read, but humans like to understand what it looks like. And the other way around too. Because if humans can understand, but not the machine, it's not very cool. You can do pipelines, you can do cool programming. So that would be probably from this data and then BIDS that comes with it, what I learned from that. The kind of second encounter with data sharing is that still from this research project, once we started sharing all the test, retest, and so on, then we collected patients, we validated the data of the patients, blah, blah, blah. And so we can share the patient's data. But now we have concerns about sharing openly the patient's data, because obviously it's a little bit trickier than sharing healthy people. But luckily in UK, we had an academic archival. And so we can go on the UK data service, and you can still access it today. I checked it this morning. But then you can see also the access is safeguarded, which means that basically you need to apply, they check your identity, and so on and so forth. It's not just click and download and do what you want. So it means you have some access control, which is good as well, right? Because this is patient's information, so we don't want just anybody to access this. Then at the time, I was also involved in another project called Brains, because we share brains. Basically just a normative data set of MRI across the lifespan. It was a little bit different because it was about hosting basically the database of all of those subjects. So when I put hosting data yourself, it's because you can't access it. This doesn't exist. Even on the website even doesn't, it is even not a redirect to somewhere else. It's like, it's dead and you don't know what happened, which is pretty shit. Because I mean, even not a redirect is kind of like, okay, that's fine. So what do I learn from these two things? First, I would say it's essential to have a strong infrastructure dedicated to data. So with the hosting, it was just hosting on where we host our website and our own local server. When I use Giga Science and the UK archival service, these are not going down tomorrow. So I have a much long-term view on how long the data will be available when I share them. So which means, locally, you don't want to share in your own lab, even simple files. You do it through the library. That's what the librarians do, and they are there to help you, and the library isn't going to shut down tomorrow. Whereas your lab website, who knows? Then access control is not a limitation, right? That makes my data still findable, accessible, interoperable, reusable. It's just that access is controlled. So access control is good. It's something that you can use. And behind the scene, we were talking too much about where it's coming from, but ideally, in my opinion, access control should not be at the hand of the people who collect the data, because there's a conflict of interest. right? Often you will say, hey, can I use your data? What do you want to use it for? Well, I think your theory is shit. I'm going to demonstrate it using the same data. No, you can't access them. Okay, but that's not how science works. So there should be different people who give access, right? You give the framework in which you can access, and then that's it. I've seen this plenty, right? But then at the same time, about 2016, when it started up to full-blown 2018, as you all know, we had the fun GDPR in place, which means, for instance, I can still share the way I was showing before because it's before GDPR, but after GDPR, I cannot use the same services. And the reason why we do that is because for biomedical imaging data, there's features in the data. So if you do an MRI, well, you can see people's face. It's easy to reconstruct. But you can also think that, there's maybe neural fingerprint. And in any case, most of the time, the metadata that we share, so there's like age, sex, and plenty of behavioral measures. And they can often be, a good source, an easy way to identify people. In any case, we know that we can single out individuals too, and that can be seen, depending on interpretation of the law, as sufficient to become personal data, which means basically for the kind of imaging stuff I do, I need to comply with GDPR. Yeah?
It's not clear at this point if the subjects are absolutely aware that the data are publicly available and if they have consent to it.
I will come to that. Next one or one after? Very good question. So a couple of issues with GDPR, which are still, is how to actually measure the risk of identification, because often we tell you, well, can you identify or not from this data? The question is, how do you measure this? Right? So the lawyer usually turns up to random guys that you don't know. He says, oh, but this guy said you can identify. Like, what's his expertise? Do you have any metric? Nope, it just comes out of nowhere. So we have another research project on actually measuring these things so we can come up with numbers. Because the lawyers, they don't know. That's not their job, right? Their job is to protect their institution. So you need to help them and come up with solutions. Of course, single out as a precursor of identifications, and people agree or disagree, depends also on the country in Europe. Issues of metadata. And then the issue of giving sufficient information to data subjects regarding the risks. Like if you say you're gonna share, you need to tell them what are the risks of sharing their data, right? It makes sense. And so that goes to the question that you were having, which is, in my opinion, the consent to share is essential. And I say ethically because depending on the country in Europe, the interpretation of GDPR and the local implementation makes it that in some places they say you don't need to have a consent to share, and some places say you must. So legally it depends, but ethically, if you follow the Declaration of Taipei, which is like what follow the Declaration of Helsinki for participants in medical research, then basically consent is essential, and also simply because you want to explain. So, for instance, the kind of things that we published in there, the idea is to say, for instance, well, you can share the data, somebody can download them, and then you can say, well, I want to remove my data. Same way as human participant can say, I don't want to anymore do your experiments. But then you have to explain them that, yes, I can remove it from the repository, but I cannot go around the world in people's server to remove it. Even if I send them an email, say, you need to remove it, how do I know that they've done it? It's impossible. We know that, but nobody says that your participant knows that, right? So there's plenty of things to consider at explaining people, okay, we want to share your data. Do you agree with that? And here are the problems that can come with it. And whether it's legal or not, I don't care. It's just ethical. I think we have to do it when we share human data. Fast forward today, part of the project for which I came to Denmark with Melanie and Gitte is to do open NeuroPet, and part of it is to host a data platform that we call Public Neuro. And for that, we partner with Computer Home, back to the infrastructure. I'm not hosting it on my server. I don't know how long we're going to be there. I guess Computer Home DTU, they're there for a while. They should not close tomorrow. Right? So we should be okay for a while. And basically, the way it looks like, so this is one of our data sets, for instance, is that now we use beads, of course, but then you can browse all the content, you can see all the files, all sorts of information, getting DOIs, of course. But now you've got all the metadata available directly, and everything is open in that respect. But then when you want to access, it's still controlled, because this is GDPR, and we need to identify users, and people need to know who it is in case there's an audit. And then people also have to agree with the term and condition. So we do things is that each data set, people just come up with their own data user agreement. So for instance, I can host data from Aarhus, but they don't have the same terms of what we do here or at Rigshospitalet. That's fine, because it's just like, this is what you want. We just host, and you decide how you want people to use your data. So what do I learn from that? Well, in general, I would say that the law is there to protect us as citizens. And the lawyers do not know nothing about our data, because that's not their job. So it's basically us who wants to share something to explain what we need. And usually, everything is possible. It just takes a lot of time. Because of course, first time I came and I said, that's what I'm going to do. They were like, nope, can't do that. I was like, yes, we can. But it took some time. Each data type is different. It has different requirements. So for instance, brain imaging and behavioral data and so on and so forth. You would have, you need to find an infrastructure that fits those requirements. And when it comes to participants and patients, but also, we have to think about working with people who, when I say animals, you see not going to consent animals, but you also have various groups related to animal welfare, and they deserve ethical and treatment beyond the law, right? It's not just good enough to say, well, the law here in this country says we don't need to do nothing, so we don't give a shit. So in my opinion, it's important to, it's not an impediment to the research. Actually, working with participants and working with patient groups and so on actually improves your research rather than the opposite. And to finish, I will my last encounter, which is an encounter of a third kind, which is code is data, right? So of course, we have data, as we know, like data we collect as research, but we also generate a lot of code. And we can also say that code is data. So here is, for instance, an example from a toolbox that I published a while ago, which you can still download and still works because we maintain it and develop it. But so the toolbox was in 2011, then 2013, I was at a workshop and where we, work on different types of data and present the tools. And then these two guys, Arnaud and Robert, and they were like, but how do you maintain different versions of your toolbox? And how do you collaborate with other people when you want to change part of the code and stuff? And frankly, I was doing it as if people send me a file and I compare the files and I do it. And they were like, hey, you're dumb. It's something called version control. I was like, okay, great. So of course, once you go to version control, you never go back. But at the time, I didn't know that exists. I'm not an engineer. I've never been introduced to version control. And then from this, of course, we had the idea of doing beads for EEG, we can create pipelines and so on and so forth. So what do we learn from this? Well, again, nothing is perfect, but documentation metadata is key. Again, really is the main thing to do when we share. Versioning exists for code and data. You can version data too. Right? There's Git annex, for instance, that will check changes at the binary level between your files. So you can version control. And versioning is essential for provenance and therefore reproducibility. And of course, data standard helps a lot. If you don't have a standard, make one. We didn't have a standard for brain imaging, we just made one. But again, grassroots from researchers, not imposed, right? Workshop, consensus, this is the only way you're going to get adoption in your field for people to adopt the standard. Because otherwise, as we all know, there's plenty of standards that people create, but it's like 5 people in the corner who say, here's a new standard. Yeah, okay, nobody cares. To finish, I would say my message would be to share and to share early your data. So you all know this diagram from academia here on the left side. We plan because we are big thinkers, we collect our data, we process, blah, 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 and at the end we share. So it can be reused. This is academia. What I say is what we need to do is science, which is you plan, you collect, you start sharing as you process, then you can finish your stuff. This guarantees that you keep publishing until death, and maybe you will at some point share the data. This guarantees that anybody who's not rich enough to collect rich data, they can access and process and come up with cool hypotheses and cool results on your data. So this is academia, this is science. And now I'm happy after 12 years or so, because I can get back to my research, maybe redo some brain stuff, no more data science, and I can share my code and data with everybody. Thank you. Yeah.
Thank you. Fascinating story, I think. One question is, do you find it a challenge to use or build your own data standard? What was your approach?
So bits, you can see that, let's go time course just so that you can see, we're still building it, huh? 16, we're like 8 years in and we're still doing stuff. So the multiple things I think that helped. First, as I said, is really the fact that it's completely open projects. You can go on the website, anybody can contribute at any time. So that's kind of like obvious. But making it open for everybody to contribute doesn't mean that you've got engagement, right? That's the issue, is how do you engage with other people? And so the engagement has multiple aspects. To be honest, Chris went and traveled the world for 2 years and just went lab to lab to just sell the product. At some point, there's no other way to really do things. It's just same as for any business. You just want to sell your product. Just putting it out there doesn't work anymore, especially nowadays, given the millions of websites and stuff, right? In BEADS, one of the reasons I would say BEADS work is the fact that indeed this is coming from researchers, that we have this system of BEADS apps. Because you have a standard, soon after the standard, people started to build BEADS apps, which means you can build tools which analyze or at least pre-process all the baseline, type of data, which also makes things very easy because it means that you can reproduce and so on. And people are like, okay, I don't need to know how to do this stuff. I can get the raw data, get something quickly processed. For you, even inside your lab, you have a new student. It takes them, no time to start with the data when they are well organized and use containerized applications, for instance. So that's also something that helps a lot. The other thing that helps a lot with this standard is that the standard is not the documentation. The standard is the validator. So you have a tool which validates, that tells you your data are bits or not. Of course, you have a website which says, this is how it looks like, blah, 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 blah. But that doesn't enforce nothing on the quality of the data. So you need to build a tool simultaneously that says, okay, this is valid or not valid. Because then it means BEADS apps, they work because it's valid. So the standard is actually, as we always say, is not the specification, the documentation. It's actually the tool. If the tool tells you it's valid, it's BEADS. The tool tells you not it's valid, then I don't care that you say, but it looks the same. Yeah, but it's not. And then everything that follows basically is because we have that. And then, of course, money, right? So, for instance, some of these that we started to do there, some of the things that I'm doing now in these is because we have money from Novo Nordisk. This is money from the Arnold Foundation. A couple of these things is coming from the Mayo Clinic. You know, it's at the end of the day, like every research project, right? No money and not much happening. NIH up to now also had people helping. Don't know anymore what's going to happen with NIH. If they're still going to exist tomorrow, but we assume that it would, at least some people will continue to help. We don't know. But yeah, I think the probably from here to about here, like 4 or 5 years, the adoption was very slow. And then, like every, you know, network theory, graph theory, when you reach about 25%, 30% of adoption, it shows that after that, that's it. So reaching that critical mass is really the key, and to reach critical mass is really going around and preaching. What you do here with the reproducibility network is the same. You go around and preach people. Hey, we need to do that. We need to do that. And why you need to do it? There's no other way, really.
So I guess the question alongside with that is, what is the factor you decide that you, because I think there were other type of standards that could also already there, existing standard for the imaging data, right? What is the deciding factor you say, you know, I cannot adopt other standards?
There was no standard on how to name things. There's standard about formats. And so, okay, another thing that shows that why BEAS works is because one of the mantra in BEAS is 80-20. Takes the solutions that already exist and works 80% of the time. We don't care about edge cases. Because you can get stuck on edge cases for like ever. So now we can go back to some of the MRI and stuff from the beginning and deal with the edge cases. But okay, for 10 years, people couldn't do with their edge case, but that's not the point. The point is we want to get most people to do most things and reuse most of the existing things. So for instance, in brain imaging, everybody was already using or mostly using Nifty. Then we're like, okay, we use that Nifty format. Same here when we done these ones. Basically, we done a survey and we looked at what are the most used formats and which are open, because there was most used format but non-open. So those ones we don't care. But from the most used open format, we're like, okay, we're gonna do tools that will support them inside the specification. So always try to go to fast, make so that it's easier to adopt, right? Because if I tell you, here's a new standard, but basically you already do 80% of the work is already what you do. So you don't have a lot to change, then you're most likely to adopt it. Whereas if I say, here's something completely new, you have to redo everything from scratch, you're like, yeah, right, I've got something else to do, goodbye. So I guess that was also one of the reasons that it worked.
Thank you.
I have a question. So you mentioned that you think that the people who give access to the data should not be the people collecting the data.
Yeah.
So could you say a bit more about how that would look? I imagine also in terms of you don't want people to go sort of fishing in big data sets, so there should be some sort of like just how would you imagine that could work also with funding or?
Not necessarily. So for instance, on, like I had to convince our boss, but now we can. So for instance, this is our data. All we have is a data usage agreement that sets the term on how you can reuse the data and so on. And nobody check who access. Well, we check as in only users who have registered and we have checked their ID, but any of those users, they can just go click online, approve the DOA online and download the data. What they're going to do with it, that's not my problem. I don't care. Why should I care about what they're going to do?
Well, I mean, the way we do science now is we kind of have this idea that you set up a hypothesis and then you test it. So you could run into the risk if you have these huge data sets available to people that, the less ethical researchers might go fishing in it and just go for interesting finds that may not really have a lot to do with reality.
But discovery is also what you do, right?
To a certain extent, but if you control through data and only publish what you want, then that becomes a problem, right?
If you look at, for instance, with this is what ABCD is doing, right? ABCD is doing this. They have like some idea about ABCD is a big data set from America about adolescent brain development. And so they started to collect. They have a little bit of pre-processing, and they're already sharing. But right away, as they are collecting, and I mean, much is like 40,000 scans? I mean, it's crazy. Like, the numbers are like, this is huge. And they just share early. And the number of people who already have published plenty of things in advance, whereas I know some other people who are here, they haven't even hardly published anything. When other people have done it. But that's not the point. The point is that you can already ask a lot of questions. And they don't really check much of what you're gonna do, It's pretty easy to access ABCD data. I mean, not in terms of infrastructure when they say, yeah, you need a 50 terabyte hard drive. But
Yes, related to, I think, who should be responsible for doing what. So, I mean, I think it's great that you did this preaching and people got on board. But who should be or could be responsible for people not playing along? So you say it doesn't matter who, like once this is all in place, it doesn't matter what people do. But one thing, so me and Amelia have seen with medical image data sets, which may contain also some neuroimaging data sets. People download it from the official source. I mean, there's not necessarily bids, but there is like, this is CC BY available. People throw away the metadata because for machine learning, you only need images and labels, right? And then you import PyTorch. And then you put it on Kaggle without any of the metadata and a comment like, all credits to the original authors, and we used internet sources to collect the data. So perhaps we can show you a figure later for like this.
poster is here.
Oh, the poster is actually in the hall, so you can see later. There's a skin lesion dataset, which is TC BY or similar. And we searched for it on Kaggle, and there in May, I think, when we wrote the first version of the paper, there were like 600 of it, different versions.
I mean,
and by now it's like 1,000, yeah.
I mean, if you take the data from OpenEuro, for instance, they are CC0, so you don't need to do the credit. I mean, to me, it's crazy that you can do it because you're like, even if it's CC0, I don't see what it costs you to credit the people from the data coming from, but whatever. So in our case, for instance, you have a data user agreement that you sign, which is legally binding. This is not like a license. There's no license in our system. If it's if it's outside the European Union, you also have standard contractual clauses between your institution and our institution. Not from the researcher, but from the institution point of view. So for instance, Stanford doesn't want our data because Stanford lawyers, they don't want to sign European standard clauses because, the fines in case you do something wrong, such as disclosing data without credit, is super expensive.
Okay, but first it's not just about the credit, it's kind of about the, and also not specifically about reproducibility because people put their data and their code there, it is individually reproducible. But then people say something like, we use the ISIC data set, and you don't know which of the 1,000 versions it is where they downloaded it. And we also had a case that a researcher from NIH contacted us, or we contacted him, because there's also NIH data sets which do not have this license, which are being reshared without the metadata. And I think he told us that he tries to email the people who reshared it to take it down. So they just get it from NIH, but yeah.
And now there are chatbots more like controlling those emails. I think that's what you mentioned. That before it was like proper email, but now it was like chatbots moderating, so like you wasn't getting an answer.
So I mean, even when we do a contract which is legally binding, the data user agreement, unless there is a breach and then you go to court,
Yeah.
let's be honest, nobody controls nothing. Tomorrow, even, because we were like, yeah, but you do that. You're like, it's not what we do there through online. We just make a process faster than what was already existing. We've been sharing data between labs for ever. That's what we do in science. Except that now you used to have a contract. Now the contract is online, but what's the difference? If the people before who break the contract and you don't know about it, nothing happened because nobody checks. So nobody checks now either. This has not changed. It's just based on trust.
All right, I'm gonna, take up time. But we have also some time aside at the end for a general discussion,
Yeah.
so I think we can get back. Thank you. So our next speaker is Melbye from University of Southern Denmark. She is a head consultant at the Department of Research Documentation and has been working on implementing and promoting open and reproducible science initiatives, both at university and also at a European level. Yeah, thank you.
Thank you. So I'm from SEU, and the day I got your emails asking for a title for this talk, I've been out talking to a department and I was just, okay, it's going to be as close as possible as open as necessary because I was so frustrated. So, but then I thought, oh, let's breathe a while, and then I changed it to as ambitious as possible and as close as necessary. But now you know where I'm standing at this. Yes, I'm the head of the research documentation department at SDU Library. We work with the bibliometrics and the data management, pure, whatever, open access. Yeah, and then I'm the chair for the pure steering group here in Denmark. So you might already discover that my focus is more on the pure side than on the data management side. So I will not go into details with data management. I have people to do that, so to say. And then I had some disclaimers, and I wrote here that I do boring slides, but then I sent them to the youngest member of my staff, and this is what happens. Then you get moving dogs. I mean, whatever. But I hate doing presentations in English, and I'm not the type who do a manuscript, so I might stumble over the words, but bear with me. And as I said, I'm not the expert on this. That is, I think some of you know Evgenius, who is doing our data management part. Yeah. So if any of this is good, it's his fault. If it's bad, then I take the blame. And at the moment, they are all out drinking beer in Odense, and I'm here. So that's how we work at my department. So, sorry? Okay, cool. Yes. Yeah, let's get to it. Okay, I've just made a short agenda about the history background and timeline and how the policy is in headlines and then what we're aiming to do with this. I tried to do a timeline on, this is also what happens, right? About the open science in Denmark. And as you may know, back in 2012, we got the first open access policies at the research founders. They were green, very green. And we also did that at SDU, and we sort of buried it in a board minutes of our board meeting, saying that we want to support green open access. Of course, nobody knew that because nobody read the minutes from that meeting. So we were out there trying to convince everybody to do green open access. And then we got the open access strategy back in 2014, and I'm not sure about 2018 about the national. Well, it was revised, and then in 2018 also somebody wrote the first open science policy at SDU, and he's sitting down there. And I just said outside that we are standing on toes of giants, so he's not that big. So, and then we have the national strategy for fair data, and then the open access policy was being revised in 23. And there we are with the national open access policy. We have the revision. We don't have the new one. We're still waiting. And maybe that's one of my issues in all of this when we look into politics about the science in Denmark. well, it's not that ambitious, is it? I mean, we've been waiting 2 years for new open access policy. And then you know how it is about data. I mean, we're not moving that fast. So, and now we're in 25 and we try to implement the policy. And then you have to click to stop it as well. As I said, in 18, the first one was launched. And then we were supposed to revise it in 23. But then, as it happens at universities, we got a new rector. And he wanted to make a new strategy for the university. And we thought, okay, let's wait for that one. Because it could be, just could be that he mentioned something about open science in his strategy. He didn't. So, but the strategy sort of moves SDU from being a teaching university to more of a science university. We're talking about trying to move from having a lot of education to have more research and have more international research. So that's the aim at the moment. The process back in time and also now is that the library is the ghostwriter for the Council for Research and Innovation. And that makes some difficulties because I think we are more ambitious than the Council is. So you have to weigh your words when you do it. So this, as open as possible, as close as necessary, has to be changed as open as sensible. I mean, it's wording, but still, why not just use the terms that we use in international open science? So, yeah. So we started on it late 23, worked on it 24, and it was approved in October 24. So, and then we write one overall policy for the whole of SDU. And as you may know, we are a multi-faculty university, and that makes some differences or difficulties because what you do at the technical department is different than what you do in social sciences. So you have to try to embrace it all in this overall policy. And then it goes out to all the departments and they have to make a local implementation plan for it and also adjust to the policy and say we want to go this way or that way. So I just took the policy in headlines and I've added a link to it. And yeah, as I said, I know most about the open access to publications, but we also included this about the researcher IDs. We tried to do ORCID mandatory at SDU, and then we were tapping our head by the DPO saying, no, you cannot do that because to GDPR. So we're sort of stuck there. I mean, simple things are being made difficult for us. We have data management plans, fair data, including software. That was a struggle as well. We have also added citizen science because we have a lot of citizen science at SDU. And then SDU, as most universities in Denmark, except for CBS, has signed the COARA agreement. Yeah. So if you want to know more in details about the data part, please look into the policy or call Evgenius. He would love to talk to you. So where are we now? The policy was approved by management. And then we wrote an email to all the departments saying, now you have to revise your policy. Some of them wrote back and said, what policy? You know, the one you had in 18. And then we did a guideline where we tried to say, oh, if you're the good pupil, then you could upgrade your policy and do this and this and this. And we also said, we are here to help you. And we are available for meetings. And if you want to talk to us, please contact us. And some of them have done that. Some of them we haven't heard of. And they had the possibility to say, we do it for departments, or you can do it for a whole faculty as well. So, and by this May, they should all be finished. I think we have 10 by now, but I mean, still a month to go. So just to give an example of the guide. Oh, can I go back? So we did these blue boxes. If you're the good pupil, then you could do this. So a sort of a way to try to improve your policy. And maybe I should add that the first policy we did was maybe more of a guideline. It was quite long. I think it was 5 or 6 pages. And that was one of the issues we were met with by this time, was saying that's not a policy, that's a guideline. So we had to shorten it and try to be more clear on what to say. And that's why we have made this guideline on how to sort of make it more usable for the department and how you could improve it. And I must say that the top pupil in the class is our Institute of Math and Data Science. They have made quite a good standard for this. So, but we try to help them do this. And now we're going out to meetings with departments, and this is what we are made with. Why green open access when we have all these lovely transformative agreements with the publishers? I was out at some professors on Tuesdays talking about green open access, and they were, who cares? I mean, and when we look into the numbers in 21, 18% of our open access was green. By now it's 9%. So, I mean, it's dropping because we have these transformative agreements. I don't know how many of you are working with open access to publications or maybe publishing. And if you ask me, those are the worst thing we could do, is to sign with the publishers. I mean, we just say, go ahead, take our money. How many believe that we have just signed with Elsevier, right? 4 years? How many believes that in 4 years, Elsevier has transformed their way of doing business? No? I don't either. But so I think we have some issues here. And we have the issues saying that, okay, we had the national strategy going green, but then we just go to the publishers and say, yeah, you can still take all our money. Doesn't matter. Just go ahead, whatever. So what we also met, that was from, I think it was from social scientists, is that citizen science, isn't that only for the health department? You could argue that our Citizen Science Center is quite heavily focused around health. I also talked to a dean saying, data management plans, why? They cost money. Couldn't you just erase it from the policy? And no, it's not needed. Who do that? I mean, and then I talked to a head of department saying, data, what data? I have a little notebook where I write some notes. Is that data? So, I mean, it comes in every sizes, and also, of course, what's in it for me as a researcher. And lately I was out also at the Odense University Hospital, and they were talking, as you talked about, reproducible data. And the first thing they said to us is, when we get a new patient transferred from another hospital, the first thing we do is to order a whole lot of blood samples because we don't trust the ones they did at the other hospital. So I'm just, okay, if that's the starting point, how are you going to share data? I mean, so it is a little bit uphill. Maybe it's because we're stuck on an island. I don't know. But I mean, there are some challenges in this. I don't know if you meet them when you're out talking to researchers. And then, of course, I took an old drawing here of open science. We don't cover it. I mean, we cover a little bit about it around open science, but not all of it. And then back to what's in it for me, where the incentives to do this. Who come and reward you for sharing your data and making a standard for it and then doing good metadata. I haven't met a researcher yet who likes to do metadata on that thing. Have you? You do? Yeah. Okay. Could you come to STU? So, but I mean, there are some issues here. And then back to, if we go into on a national level, where's the ministry in this? I mean, the Ministry of Research, well, I think that's probably the ministry who changes the minister most. And it's always a new person. It's always somebody who don't have any career within politics before. And so they're green when they come there. They don't know anything. And then they're out by, I don't know, 1-2 years. And then not because they're promoted to another ministry, they're just out. So, I mean, it's hard to get somebody in here and talk about that. And I mean, I think that's one of our issues about this. Because if we had some more political awareness about this, I mean, we keep talking about Denmark is a land of knowledge. But it's not shown that we want to share our research. So, so just what we want to do now. Well, we're waiting for the dark database because we have mentioned it in our policy, or are we? I'm not sure yet anymore. I'm not sure. As I said, I worked with Pure, so I'm a little bit confused. Maybe, just maybe, we could do something else. And but who knows? And then we try to practice what we preach. So SDU Library also have an open science policy. And we also try to do bibliometrics according to the QR guidelines. So, and that's sometimes a little bit of a struggle. And then I borrow some slides from Igenius, and maybe some of you have seen them before, about the Oado Award. We want to try to promote open access and open science and open data. So they have made, some of the smart guys in my department, they have made this, and I will not go into details with this, but you can have the slides and you can, but we will try to do some calculations for our departments and try to look into, is there a research group who performs good, and then, I don't know, probably won't have money to send them a whole lot of money to do more open science. Maybe we can send them some coffee mug with Oado label on it. I don't know, but we would like to try to promote people who do things and do them right. So, yeah, and that was my speed talk. Yep.
Question about the quality.
Yeah.
In relation to the GDPR part.
Mm.
What is that? Because ORCID is kind of also, this, the DTU, in our departments.
DTU has made it mandatory, I know that.
Yeah.
And you're supposed to give your ORCID when you sign your contract with DTU.
That I actually don't know.
Oh, yeah, that's what I heard at least.
Okay.
So, yeah.
So what is the problem?
The problem is that our DPO don't think that we can go out to a research and say, you must create an ORCID, and then you must put it into Pure, and you must do the, what do you call it? See, I lost it. The synchronization from Pure to ORCID, so we can talk together.
Yeah.
And
why is that GDPR still? I don't get it. I still don't get it.
I don't either. But I'm not the DPO, right?
I'm just a person.
You want to try?
So I remember the tech faculty try to enforce it, and I think it has to do with the consent and involuntary. And the only way to get around it really is to write it into the contract, your employment contract. If you write it there, then you know, okay, this is a condition, I can live with that, you sign it, then it's okay. But to go the other way around and demand it from all employees would not be a voluntary consent.
But I mean, it doesn't make any sense today, because every publisher wants to have your ORCID when you submit a manuscript, and I mean, so I don't get you in this, but
this was also the case just after GDPR.
Yeah, but we tried it again. We tried it, and yeah. Our DPO is not an easy person to work together with, to say the least. Yeah. So
thank you.
You're welcome.
Can you explain a little bit what Oado is?
Oado is a way to look into how you're performing on open data, open access, and you compare it within your department. So it's not that we try to compare apples and pears. We try to see within your department, how are your research group performing?
Is it the metrics that you came up with?
Yes, yeah. Homemade metric. Yes.
I was wondering, have you are you in dialogue with other stakeholders such as the funding agencies? Because there are many, buttons and screws you can. I imagine that, follow the money is a good way.
That's always a good way
to get the
to go.
funders on board with implementing or having sort of criteria, then that can probably be a way to enforce some stuff even unofficially.
Yeah, and we are trying to do that. But still, it's always depend on us getting in dialogue with the department, right? And some of them we never hear from them, so they just go with their own flow. So, but I think something will be coming because we're in dialogue with at least Novo and Willem Velux in regards to do reporting from Pure. So there can be some benefits in collecting data and try to have it all in there. So researchers don't have to go into research and do their reporting. So
it is a research fish, just to comment on that, it is a research fish, but I think research fish, you get with your orchid, imports all your publications, then you say this one belongs to the project. I can say that DFF does not do this because it asks for my orchid, and then I have to click add publication. Each time. I like doing metadata, but not my metadata that's already in orchid.
No, I can get that. But DFF are also the front runners on Quora in Denmark. So they're moving fast, and they are planning our international conference on Quora for December when we have the chairmanship for the EU. So there will be a whole lot of stakeholders coming to Denmark talking about Quora.
Any last questions? Otherwise, telescope tour for those who are interested. Yes, thank you.
You got it here for the first time. There is a restroom just here, but also if you walk down this hallway, there's.
Okay. No, that's fine.
Perhaps that's Atlantis. There's not one in here.
No, that's fine. It's not like there's very much space.
Is anyone this my buddy? Are we missing? People in general. All right, I'll just introduce the last speaker of today. I'll introduce the last speaker of today, who is team leader at the Department of Clinical Medicine at the Steno Diabetes Center at Aarhus University. And apart from the diabetes research, you're also very involved in open and reproducible research and currently working on developing software that will help researchers access and deal with health data in the best way possible. So thank you.
Nice. I don't even have to explain that part. That's great. So I want to make a comment. Was it Anna? Yeah, your slide about not being good at speaking English, or not like I'm an English speaker and I also have a hard time speaking English. So we're on the same page. So especially in the morning, I have a really hard time speaking in the morning. It just tumbles all out. But so I when I got invited to talk here today, it's about research culture, and I've been really doing a lot of work trying to improve research culture. So I was like, oh, this is great time to share my experiences. And also thankfully there was also a lot of challenges that already came up in the other two speakers. So I'm gonna talk about some challenges. And when I practiced yesterday this talk, there was a lot of ranting. I have a tendency to rant. So there's no clock, so maybe just somebody make sure to keep me on time. Yeah, exactly. Or speed up. But I think I will limit some of my ranting a bit for sake of time. Okay, so yes, that's already been introduced. If anybody wants to, this is a website. It's online. It's slides.lwjohns.com. I put all my stuff. When I do open, this is everything I do is open. You can go to my GitHub, and literally every work that I do, every conversation that we have within our team is on GitHub. It's through issues, it's through pull requests. Everything is open. So I really do heavily practice what I preach when it comes to this aspect. I teach 3 workshops for the Danish Diabetes and Endocrinology Academy. I teach them every year. So there's 3 of them. Right now they're around reproducible research in R, so how to do reproducible research in R. And there's the introduction, intermediate, and advanced. You can see them. I'm not going to go into them, but these are the links there. We do also have some workshops that we're developing for Steno Aarhus for introducing them to using GitHub, as well as a workshop for how to work collaboratively as a team using GitHub and Git. So and yeah, I'm not going to get into this too much, I've already been introduced around this, but just most of my work right now, I don't actually do a whole lot of research anymore. I really transition into like research and software, almost entirely right now. So right now, that's the main project. It's called CCase, and it's around building infrastructure for data. But so I always like to come into a talk with a purpose. What's the reason for listening, and what should you maybe remember at the end? Mainly, it's to share some of my experiences and rant also at the captive audience a little bit, and hopefully, like maybe share some insights in like how other people can avoid some of the mistakes or challenges that I've encountered, and some lessons learned. Which I'd love to see that there was already some lessons learned shown today. So through that, the way that I'm going to like achieve my objective is I'm going to focus on 3 things. The UK Biobank project, which we at Steno Aarhus University, we have like a project that we applied for data, and we have PhD students, postdocs working under there. So that's the UK Biobank project. There's a national project called DP Next, which I'll mention later on. And that's a project funded by the Novo Nordisk Foundation. And then I'm going to talk a little bit about community building, largely around using GitHub within across Aarhus. So those are the 3 things. First one is UK Biobank. Has anybody used the UK Biobank at all? Has anybody looked at the UK Biobank? Is anybody aware of the UK Biobank? Okay, some people are aware of it. Great. So myself and a few others, we got together, and what we wanted to do was start building up a better research culture. And so we started by having an application to UK Biobank, because that's easy. The data is already available, and we don't have to do any like designing of studies, collecting data, getting a lot of money for all that stuff. So it was a really good chance to start like building up a better research culture. So that was kind of like the main aims of that particular project. We wanted to build up processes and workflows for how we can work as a group, applying these open and reproducible practices in a collaborative way. And we also wanted to start building a community around this project within Steno Aarhus, because as I'll explain a little bit more, I already have some like people who are strong advocates of openness and reproducibility. So this is one of our first steps. And this started, I think, in 2022, beginning of 2022, maybe beginning of 2021. I can't remember the exact date. But the way that we were going to achieve this is what we're going to do is when a PhD student or postdoc apply for a sub-project within the UK Biobank, what we wanted that sub-project to be able to do is right from the beginning, it's going to be a fully reproducible by the end. That's what our aim was. Version control, so using GitHub. There is a code. I'm going to explain this a little bit, but there's a GUI for clicking and requesting the exact data that you want. But that's not really reproducible because like click, click, click. It's also an agent PDF. But so we wanted a code-based way of extracting that data. And then also code reviews throughout at regular time points. And then we wanted to publish the protocol and the preprint and the code. And I'm going to explain the website a little bit more later. But I did just want to, I'm never good at Mac and clicking. So I just wanted to, I don't know if I can zoom in or not. Anyway, maybe you can, this is actually, might be, this is good enough. There we go, thank you. Yeah, as you can tell, I'm not a Mac user at all. But so just really to like highlight what we ended up deciding on and like how the process should be is somebody else submits for a proposal, it gets created as a pull request on GitHub, we, the committee, review it, approve it, then we generate the project for them. They create a protocol, they upload it to Zenodo, they work on RAP, which I'm going to explain in a bit. We do some code review, blah, blah, blah. And then finally they write the paper and upload the preprint to Zenodo. So that was kind of like the overall workflow that we've envisioned and communicated to people applying to this. My personal aim, my personal aim for working on this was largely around like how to streamline the administrative project management side of stuff, like how to make it easier for us, like that step of if you make a proposal, like how does it get automatically added as a pull request to the GitHub repository? How do we automatically just create a project for the person, the researcher, and so on. So that was my main aim. I like to design things that make it easier for researchers to do their jobs and also like administrative people to do their jobs in a faster way. So keeping that in mind, the really nice thing about UK Biobank and RAP in particular, so RAP is the research analysis platform. It's from DNA Nexus. The really nice thing is that every single time you work on the data, it creates a new environment, completely clean, and you have to install everything yourself. There's none in your files, nothing is there. You have to set everything up every single time. So that's like perfect recipe for trying to be reproducible, because imagine having to do everything manually every single time, like extracting data, blah, 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 running everything, keeping everything up to date, pain in the ass. But really great opportunity for trying to be reproducible and setting up the workflows for that. So that was the really great opportunity. One of the biggest challenges right from the beginning is RAP is a total fucking mess. It's terrible to work with, really, really bad. It was started right from the get-go. How many people use R? Okay, how many people use Python? Okay, so you can see I guess there's also a lot of neuro people here. They use more Python, but at least within health research, like medical health research, R is mainly the main thing. Almost nobody knows Python. So like we were all going to be using R, but RAP is mostly designed around people using Python. So the documentation around that of like how you can just get started was not really present. Which brings to this next thing. Documentation was almost non-existent, or it was existent, but it was very clearly that DNA Nexus had like a very low priority for this, and it showed, and it was really hard. I'm a very technical person. I use Linux. I know how to like dive deep into the internals of like what's going on, and it was super hard for me to figure out what was going on with like just anything within their system. So I can imagine as a researcher who isn't as technically minded as me, would just be like, I give up. And it kind of actually showed with the number of people who initially applied for our project, and then the number of people who actually continued. It was like a lot of people were really interested, and then they saw how difficult it was, and then it just went down to like a couple of people who actually continued. And I think this is one of the big reasons. And it was such a low priority for DNA Nexus that UK Biobank actually ended up having to write a lot of their documentation themselves to be able to show how to actually use the RAP. So kind of that was the biggest challenge. And it's already been mentioned, documentation is key multiple times. Very good. The next big challenge was that the data, extracting the data, you'd think would be super easy, or like, oh my God, it was such a pain in the ass to actually get that process from here's the database and extracting that the necessary data for a particular project. Just as an example, they changed their code. So I built an R package, or I started writing some R code to interact with their system, and it depended on some of their code that they had built. and they just randomly changed the behavior of some of their code. And at one point I was like, I don't understand what's going on. It's just I didn't change anything, and now everything's broken. It's because they could change something in the way that some of their code behaved. Almost impossible to test it locally. You have to like run it on their system, and then the errors that you get back. So these are some of my commit messages when I was working on this. It's like, rap is weird. It was just really difficult to actually figure out what's going on. And again, I'm somebody who likes to dive into this type of stuff. And so other people, I can imagine, would have an extremely hard time doing this. So, thinking in mind of building research culture, documentation and consistency is so important, but unfortunately, it's not super high priority. So I finally made an R package to help the others out. And I did want to show off a little bit of this. I've already shown the website already. But just as an example, so every single time you start up the wrap, as I said, it's a completely clean environment. So like there's going to be a lot of steps that every single PhD student, researcher has to take to be able to get to that point of like actually starting to work on the data. If this works, there we go. So I kind of was through several like iterations now, like rather than having like this complicated series of steps that they have to take to be able to like get everything set up, I kind of simplified it down to one command they have to run right from the beginning, and it asks them some questions and then it does everything for them. So it's like it saved them a ton of time, and also highlights the value of like writing code for even if it's like a super like local particular project. And then the other thing I wanted to mention was about my personal aim, which is around the administrative side of stuff, is, for instance, after they get approval, rather than have to do all the setup myself, I set it up so that there was one command that I could run, and it just would create everything for me and automatically assign the people to the right repository and give them all the correct access and everything. So all of that to say is reproducibility isn't just around like, or building up effective research culture isn't just around the culture itself, it's around the tools and the processes. Things that are easy are going to be more likely to be used. And no, it's over here. It's a little hard to see. Yes, so, and then the next set of challenges was reviewing code. How many people like formally review code on a regular basis with their PhD students or postdocs or whatever it is?
What do you mean by formally?
Like through, for instance, pull requests. You actually go in and refactor code to improve it. Yeah, I'm happy to see that most people have also not had that, because before this project, I also didn't. I mean, I didn't really work with people in that particular way. And because it was one of the aims that we had, like this was something that we wanted to try out, and it was something that I wanted to try out. It was very enlightening. I will tell you, it was a very enlightening experience to review postdocs and PhD students' code, because it also highlights many of the challenges that we still face, which I'm going to get to in a little bit. But I wanted to just like highlight just one, maybe I'll just highlight one example here of, for instance, sometimes like PhD students or whatever would say like, oh, but it runs. Just because it runs doesn't mean it's giving you what you expect it to give you. Like, you don't know that until you actually formally test it. And this is like kind of an example of like what I'm kind of meaning. This is code to clean up the output of a model for just one model. And they were running multiple models. So they had probably like, I think in this particular example, it's like 1,000 lines of code of basically just copy pasted, which could have been simplified by using one package called Broom. Oh, you can't see it there. that has one function called tidy. So just some small little things could have saved them a ton of time because they wouldn't have to write this, and it's super error prone. It's like, it's basically the same every single time, except the only changes are here and here. So very enlightening doing formal code reviews. I'm not going to show the other example just because I could easily just rant about this a lot. But it's probably a reason why most of you haven't done it, because it's a huge, huge amount of time to do this. And not just time, like energy, because you don't want to just like tell them, oh, this is like, redo this. You want it to be like a learning experience. I'm a teacher. I like to have people learn and not just like feel like they're kicked out. And so I really tried to like write things in a way like, this is like, do it this way because of this and this, which takes up a lot of time. And this doesn't really get you anything from an academic point of view, reviewing stuff. We already know like finding reviewers for papers is really hard. Now finding reviewers for code, good luck. And this is so much work. I'm telling you, so much work. It's basically only done by me. The others just literally do not have the technical skills to be able to understand the code enough. And in all of Steno, I'm literally one of the only ones who have that much technical skills in this area, technical knowledge. And so that's a lot on me. Huge burden on my end for very little actual academic credit or like career potential. And I completely understand. We have so much pressure to publish. Like PhD students, you got to have 3 papers out. If you're a postdoc, you need to have papers because then that guarantees a job in a career, gets you funding. So much pressure to publish. It was already mentioned, you're not an engineer. We should not expect researchers to know how to do coding. That's such a, like, I mean, there's so many things that's like total bullshit that we have to know all these things just to be an effective researcher. Stats, project management, teaching, coding, like so much. And we can't do it all. It's impossible to do it all because it's so much work. All the while we're being pushed to publish. And you can't create an output from reviewing code. That's just an example. And I think a big thing is we researchers, and also particularly like PhD students, postdocs, early career, you're rewarded for getting it done, or you're rewarded for getting it published, not for getting it right. And this is really clear when you look at some of there's now actually data on reproducibility. Reproducibility is like rock bottom. I mean, it's almost non-existent within most published research. So we're really not rewarded at all for getting it right. And it shows very early on, and it shows in examples like this. So I actually had to take a big step back because this was last year that I had a lot of this was happening, and because I was just burned out. It was just way too much work. I felt really responsible for them, but it's like I can't. I'm just one person. There's no way to do this on my own. And so one of the main things that I really learned, because in this process, I also was working as a team on a software project. We review each other's code all the time. Anything that gets into the main branch is very well reviewed, oftentimes like for a week or so before it actually gets merged in. We have formal engineering processes. We have software engineers working with us. Like, that's what we freaking need, is teams in science. Not just like solo researchers. We need teams all working together on the same thing who have different skills. It's just ridiculous that we're expected to do all of this all on our own. So I think that was the biggest thing, is like we need more teams. That kind of ties a little bit next into the next project. And please make sure to tell me about the time, because I can keep ranting a lot about this stuff. Is the Steepy Next project. So it's Novo Nordisk Foundation has this like national collaborative grants that they host every year. And the aim of those grants is to get all the Steno centers working together, doing something. So it was one really great chance to like try to like sort of indoctrinate the other Steno centers. It's already been done mostly at Steno Aarhus, and now it's like next ones. The PI of this was my previous postdoc supervisor. He was also involved in the UK Biobank project. There's a couple of other people who have also been from the UK Biobank project. So we took a lot of the lessons learned. We're starting to apply it here. And I don't know if oh yeah. So I'm responsible for work package 1. And that's the main aim of that is better research in less time and fewer resources. So that incorporates openness, because it's my strong belief that if you're open, if you're reproducible, you're going to be doing better research, and it's going to be in much less time at the end, because you can automate a lot of the things as you go along. And I think maybe I'll very briefly show the design. So one of the lessons learned here was around having much stronger guiding principles. I think guiding principles are really kind of like policies, or we were mentioning policies, they're a way of as a group being able to have a document to refer to when we're doing stuff. So it's a way of just saying, this is what we've agreed on, this is what we're doing. And having a specific set of to make it super clear for people who are coming on board, this is what we're using, this is how we're going to be using it, these are the processes that we're doing, etc. So this is something that is kind of highlighting some of the lessons that we've learned from the UK Biobank project. Is really strong top-down. So he's the PI, he said, this is what we're doing, full stop. We have tech leads. So within all the different Steno centers, they have a local person there who will be responsible for the more technical side of stuff. And they're there to be able to help, encourage others to be doing more openness and reproducibility. But part of the aim is that they're going to learn, we're going to be all together, and we're going to all learn and figure out problems and try to work through issues. We're emphasizing way more training, because that's really something that I see a lot of, is training is a really important component of all of this. And then just in general, having a clear roadmap like I showed there. But I think the biggest thing, so we haven't started, it's going to be September, is when it's going to start. It's still one of the biggest challenges. How many people use GitHub here? Okay, a really good portion. So most researchers in my field, or where I work, almost don't even know what GitHub is, and they're kind of a little scared about what it is. So we're going to need a lot of training and education around that. So that's going to be a really big challenge, which kind of ties in a little bit to this community building across Steno. Yes, so this is the way you build community. In my experience, you rant. You rant all the time. I in all my art courses, I rant, and all the students all the participants are listening, and they have to. I mean, they don't have to. They can leave if they want, and they don't have to attend the next ones, but they happen to do. So they clearly like ranting. So I think ranting is, if you want to build community, is a really effective way of getting people to know about the issue, and you rant often enough. So if anybody knows the science of learning, repetition is one of the key things of learning. You repeat often enough, you're a broken record. I sometimes do feel like I'm a broken record, because for the last 10 years, I probably haven't really changed the way that I've been ranting. It's basically been the same. So you start ranting often enough, and then people start listening, and they're like, oh, that's kind of right, actually. And then you rant so much that they're finally like, either they just give up and they're like, all right, Luke, we'll do it. Or they start thinking, oh yeah, no, you're totally right. Like, let's start doing this. And that's kind of been my experience within Steno Aarhus. Is like a lot of people have been hearing me rant all the time, but then also like seeing the impact of like, I've been ranting, but also trying to do stuff, improve things. So they see like the benefits, and then they also hear the ranting. So then it's kind of like a nice like mix. And then now they start actually being like, oh, let's start doing that. So I think largely through a lot of my ranting, and it's been said, many people have told me this, because of this ranting now, Steno Aarhus has more or less said that they're going to adopt GitHub for building websites, for putting material up online, etc. So it's kind of like a nice, at an organizational level, they're just agreeing to use GitHub for these things. Not the reproducibility side, but at least the openness side of things. The reproducibility side, I think, can come along with it eventually. But one of the initial reasons why we started using GitHub was we needed a place to store like common documents that researchers come. I don't know what everybody's like affiliation situation is like, but those who are working at Steno Aarhus, it's a combined region with university sort of. So we have people who are employed at the region, but also employed at the university. So then like, if you're, for instance, like working in the region setting, you're using their version of the Outlook. That's just a basic example. So like, you can't necessarily see the calendar versus the university. You can't also see the calendar. So like coordinating people, we can't use like internal only facilities or internal only services. We have to use something that's external because we have people who are outside of the employed IT environment. So that's what we did with GitHub. And I'm not going to show that. But now several other websites are being hosted there. So we're putting more and more of the stuff up online. So I think that's kind of like a nice like showing that you do this often enough and rant often enough, and people will start start moving over. And the UK Biobank sub-projects are also all managed through this GitHub organization. So that's kind of like a nice way for discoverability of like what's going on across Steno Aarhus. I think the challenges will keep coming. One of the ones right now is like one of the sections at Steno has just said everybody has to use GitHub for making websites. Full stop. And so now a lot of people are like, oh, like, you know, with the chicken with their head cut off, you know, oh, what do I do? What's GitHub? So there's going to be a lot of need for education and training to like help massage there. It's okay. You're fine. You're fine. We're all here to hold your hand and get you. But then there's like other stuff around like web accessibility misunderstandings from like the region point of view. I don't want to get into that rant because I literally ranted to myself for an hour related to this stupid topic. But so I think one of the biggest things about trying to build up the community and ranting all the time is that it does help you feel like you're not alone, because you can definitely feel like you're alone talking to the wilderness. And I think most people could probably appreciate this feeling. Yeah, so kind of to sum it up, I think there's like a couple of, I think there's maybe a big lesson that maybe it's a little pessimistic, but my big lesson that I feel like I've learned is, does anybody know what Conway's Law is? Conway's Law is like the observation that the structure of an organization or how people communicate within an organization dictates what it can produce, what it can build. So in the context of software engineering, as an example, the way that you organize teams directly impacts how those software and the quality of the software that is built, as an example. The way that academia and research in general is structured, I have a hard time seeing that we can actually, at a global level, be able to institute effective, open, reproducible change. A really pessimistic view, because we need more digitally competent people or technical people in research. What ends up happening? They go to industry. Because you get more money, you get like time, like you don't have to stress about where your money is coming from, grants. It's just a little bit of a nicer experience. And multiple times I've tried to reach out to people who like I found a paper that they're doing some really cool stuff. Like, oh, like I want to be able to like invite them for a talk. Can you guess where they are now? Yeah, all of them are in industry. Almost every single person is in industry. So it's like a brain drain. And it's just the unfortunate realities, because like software doesn't get recognized as a legitimate output. And that's one of the key things we mentioned about like incentivizing. And software is so hard to build. Like I think software is way harder to build than doing a research project, because at least once you publish, you're done. With software, you have to maintain. then you get users, and then you get bug issues, and then you get, oh, what the fuck? And then you're like, this design decision that we made early on is a terrible design decision, and now we have to deal with that legacy situation. Or like restart from scratch. It's a lot of work. And like, if there's no structure in place to like ensure that people actually stay to do this stuff, they're just going to go away. We need funding for this stuff. Like, so this current project that I'm on, we did get funding from the Neurobiology Foundation, but it's literally the only thing that I've ever seen around formally giving a software project funding, a software training project funding. I haven't seen anything else at like a large enough level to be able to employ a team of people, and they cost money. And we really need team science. And I think it's really hard to like implement like the way that we do PhD students, for instance. You're on your own mostly. That's not team. There's no team science there. So we really need that for, I think that's what we need as lessons learned. And if we do want to implement change, I think we just really got to keep ranting and keep ranting and keep ranting, and then also trying to improve some situations or provide solutions. Yeah, that's, I will keep ranting, but I think I will stop.